dear student, I'm Mr. Kitwala from Educatiz. I will be with you in physics for Form 5. And today, my dear student, we are going to proceed with our discussion for our subtopic of fluid dynamics, for the subtopic of Bernoulli's principle, as we tried to explain on the last sessions. So welcome again for our discussion here. Before we proceed with our discussion, now we were supposed to remember where we ended on the last session. On the last session, my dear student, we tried to explain some applications of the Bernoulli's principles, the way we can derive the Bernoulli's principle and the place where the Bernoulli's principle can be applied. We tried to look on different methods, different applications. One of them we looked about the ventrometer. This is an instrument used to measure the liquid, like the fluid, like water and also the oil. That is what we ended on the last session. But on our today discussion here, we are going to see another application of the Bernoulli's principles or Bernoulli's formula that we derived on the last session. This we have the atomizer or spray. This atomizer or spray, my dear student, is also the application of the Bernoulli's principles. How this become as the application of Bernoulli's theorems. Let us read together our statement so that we can understand more. So the atomizer or spray, as indicated on the figure number 80 for our topic number 5 here, is a device that is used to spray a paint or an insecticide. When the rubber ball of the atomizer is squeezed, air rushes through the narrow neck of the device, in so doing the pressure in the narrow channel at a point become reduced. So this is an instrument. This is an instrument used to spray a paint or insecticides. We see more sprayers that are used in the farm, that are used when we build, when we want either to paint to produce the color on the building. We apply the concept of spray because we reduce the pressure by squeezing. If we take that sprayer, my dear student, and if we take that atomizer and squeeze it, it means the pressure can be reduced. The pressure can be reduced because it causes the air to rush through the narrow necks of the device. It causes the air to rush through the neck in a narrow neck. Kwa kinamna spray inavyokuwa inatoka, this obey the concept of the Bernoulli's principle because it reduces the pressure. The pressure and also the speed of the spray creating the relationship, because when the spray inside of this atomizer, we see the spray being in a station. It means kwamba ipo kwenye rest. It means ipo kwenye rest. So it need energy to be converted because it's in the form of energy ambayo tunaita ni potential energy. Kwa hiyo inakuwa inahitaji conversion, kuiconvert ile potential energy kuipeleka kwenye kinetic energy. This is why we explain about the atomizer or spray. Kwa ukibonyeza pale ukikandamiza ile spin ile atomizer, ukishaikandamiza pale ile rubber ball, if you squeeze that rubber ball, my dear student, it can cause the air to rush through the narrow neck. Mwisho wa siku utakuwa unaiona ile spray inavyokuwa inatoka. Kumbuka inavyokuwa inatoka pale inatoka na pressure kubwa sana, inatoka na pressure kubwa sana, kwa sababu sehemu inayotokea pale kwenye nelo na neck, there is the small area, there is the small cross section area. Kwa kama kuna small cross section area, basi inatengeneza pressure ambayo ni kubwa sana, na mwisho wa siku unakuwa unaiona inavyotoka, inatoka na pressure kubwa sana ukilinganisha na namna inavyokuwa inatoka kwenye ile rubber ball. This is how we explain about the atomizer or spray as the application of the Bernoulli's principles. As we see, we have our figure that represents the structure of the atomizer. This is our figure which explaining the structure of the atomizer. So here we have the rubber, and here we have the air. This is the air, the motion of the air. And here downward here we have the insecticides. This is the insecticide, and also we have the A representing the cross-section area, my dear students. So as we see that when this ball, my dear student, is squeezed, when this ball is squeezed, it causes this air to rush through the narrow tubes. When it rush, it leave out from this narrow annex. But when it leaving, it create the highest pressure. It create the highest pressure which create the highest pressure which level is the highest speed, as we try to see. Kwa nini tunasema inakuwa na create pressure ambayo ni kubwa sana? Kwa sababu kwenye narrow necks hapa cross section area ni ndogo sana. Kwa kama cross section area itakuwa ni ndogo, basi kuna uwezekano wa kutengeneza pressure kubwa sana. Ndio maana this spray which is leaving out through the narrow necks, it come with the highest pressure. So my dear student, after this one, as we observe that once the pressure at A is reduced, when the pressure at A, this point A is reduced, atmospheric pressure pushes the insecticide. Kwa ile pressure kwenye point A inapokuwa inabidi reduced, kwa huyu atmospheric pressure ataweza kupush ile insecticide up the tube. Kwa ataisukuma ile insecticide up the tube toward the narrow channel. This the insecticide is then pushed outward into a fine spray or droplet. Kwa hiyo utaiona sasa baada ya ile pressure kubeni reduced at point A, tunaiona ile insecticide ile atmospheric pressure itaipush ile insecticide kuweza kuweza kuelekea kwenye zile narrow channel. Ikishafika kwenye narrow channel, ile narrow channel, my dear student, itasababisha ile spray iweze kutoka kwenye matone in forms of the droplet or in forms of the fine sprays. Utakuwa unaona kama vitone vidogo vidogo sana vinavyokuwa vinatoka vile vya spray. Kwa the way this is how the concept of the Bernoulli's are said. So after this one, my dear student, let us see another application, which is called the pitot tube. This pitot tube, my dear student, is also the application of the Bernoulli's principle. What is the pitot tube? This is what we are going to see how we can explain. On the pitot tube, my dear student, we are going to see only two pipe. Those pipe are being dropped into the narrow tube. Kwamba tuna narrow tube, lakini tukachukua pipe mbili, pipe ya pili ya kwanza na pipe ya pili tukaidumbukiza mle kama inavyoonekana. Yani the way the narrow tube, the way the capillaries work, the process ambayo tutaenda kuifanya hapa. So the pitot tube, or sometimes tunaita ni flowmeter, hii pitot tube. This is the device used to measure the speed of the moving fluid. Kwa pitot tube ukiambiwa kudefine, ambao sometimes tunaita ni flowing and flowmeter. Kwa hiki ni kifaa ambacho kinatumika kuweza kupima the speed of the moving fluid. As we want to determine the motion of the fluid, we use the pitot tube so as to determine it. Kwa instrument used to measure used to measure the motion or the moving of the fluid, the motion of the fluid, tunaita ni pitot tube au sometimes tunaita ni flowmeter. So it is very often used in airplane to measure the relative the speed. So this is used in airplane. We see at the airplane, such as aircraft and so on. They use the pitot tube so as to determine the relative velocity. Kwa ukitaka kudetermine relative speed kwenye airplane, lazima uweze kutumia hiki kifaa kinachoitwa ni pitot tube au sometimes tunakiita ni flowmeter. So the schematic diagram of the pitot tube is shown in the figure. Kwa sasa tutaenda kuangalia ile schematic diagram, ile figure ambayo ina explain about the pitot tube, my lovely students. But kitu ambacho unatakiwa uweze kukeep on your mind that pitot tube is like the flowmeter. It involves only a tube. The aim of having this pitot tube is to measure the velocity of the moving fluid. We want to identify the motion of the fluid. The motion of the fluid, we use this concept, and always this is applicable on the aircraft where they use in order to identify the relative speed. So let us go and see the schematic figure that representing the pitot tube, my lovely.